Hello everyone, D. Alfred Ostrowski here. Welcome to day 5 of my 20-day Ethereum challenge. In this recording slash demo tutorial, I'm going to be presenting a slightly more advanced smart contract that's going to support a voting application. I've done an earlier version of this about a year ago. I'm going to include that in the documentation. This has been enhanced to support Node 22 and also have some enhancements to support advanced assertion testing and some slight modifications playing around with the accounts, as well as demonstrating some of the dynamics of working with asynchronous functions. So as usual, I'm going to be leveraging a C5 instance, and if you don't have prior experience, you'll want to look at some of my earlier videos, and I already have the prerequisite software already installed. Everything's documented on my GitHub. If you want a little more details on that, you can look at the day 0, and I'll also be putting together, as I mentioned, some supplemental recordings working with some of the basic technologies that I've been leveraging in these videos. For those of you who have no prior experience, again, with the goal here to get you up and running from 0 to 100, working with these Solidity smart contracts in cooperation with React.js and ethers.js on the testing side, and Web3 with the React.js side, and also leveraging Hardhat. So I've already started the instance. Again, as mentioned, I have the prerequisite software installed, and just referencing my own documentation here I'm going to be stepping through. I have all the first 11 steps here with the node source installation and some of the software that I'm not even going to be leveraging at this point, just to be consistent with the installation. Of course, we can run multiple React.js projects and corresponding Hardhat installations under the same node. I also took the liberty of running create React app for my voting application, and that is under home Ubuntu. So I'm going to create, which I did create, a project directory that's called voting, for React.js. Within that, I did a Hardhat init. So when you do this, make sure that you're in this case, the voting project directory to run Hardhat. I already have Hardhat installed, and that's good to go. All we have at this point is to load in the 5 files, configure them appropriately, then we can start running the assertion testing against the smart contract, run the smart contract, and explore some of its dynamics and explain it and break it down line by line. So let's move on ahead here. Again, I have everything up and running. I have my 2 terminals, and again, I've installed Hardhat. I've installed create the React.js using create React. And now I can go into, you want to keep track of the associated directories and make sure I'm working in the appropriate project directory. So I'm going to go into the Hardhat config file, and I'm going to copy in my updated Hardhat config. All I'm going to be doing here is configuring the DNS appropriately. And again, if you started that instance, you want to make sure that you have the security rules set up. I use all traffic IP4. You could perhaps use a little more specific configuration, but this gets the job done, and I'm not worried too much about security, as this is just a sandbox environment. Now I've broken this down a little bit more in other videos, and I don't want to repeat myself, so we're going to move forward with the next steps here. So now I'm going to pull in the smart contract, and I'm going to speak to the smart contract line by line at this point, because I'm going to be immediately doing the assertion testing. So let me load it in appropriately, and we can take a look at the code. It's not a lot of code, however, we've expanded substantially beyond the last example. So if I go into the context directory, I notice that Hardhat puts a lock.solidity file in here. I'm not going to be leveraging this, so just for simplicity, I'm going to remove that and create a new file called voting.solidity. I go to my contracts directory again. I have all of my code is backed up to the associated GitHub for the day 5 tutorial, and hopefully you can just cut paste right along with me and get it up and running, and most importantly get the intuition as to how to change and modify the program to suit your own personal needs and get ownership, start changing the code. That is after you get it up and running. So let me step through the Solidity smart contract here. I have my pragma Solidity that's indicating a compiler greater than or equal to 0.80. I named the contract voting. I have two data structures here at the global level. First is in a mapping structure, giving me an associated array key value string to a uint 256 for the votes received for whatever the key value might be. And I have the key values listed explicitly as an array of strings, which I identified as candidate lists, and here leveraging square brackets to reference that. In the constructor, I actually hard-coded two values for my candidate list. Now, moving forward, you might want to pull that out and put it in the deployment script and use, let's say, a contract factory and pass that in, and then deploy it from that point. Here, just for brevity, I pass it in as the constructor, as I have hard-coded values in my application as well, so I didn't remove all the configuration out either on the React side or the smart contract side. Following that, I have a function that's simply going to return the votes received for a given key or candidate in this value, and just referencing that hash structure by pulling in that string and returning the value. Here I use a similar mechanism just to increment the uint for that particular candidate, passing in a string, a memory candidate, and identifying that as votes received. So these are all public functions, and I'll be able to invoke them directly from both my assertion testing as well as my React.js application for my decentralized application here. I have a test for a valid candidate. It's going to receive a given string and then work at the publicly declared candidate list, working through the entire length. I'm not bound by a specific index here by using the length function, right? And each one, I perform a test on that. Now not using more traditional string compares I might in other languages. Here I do a bytes conversion and use the CCAC 256 to allow for a string compare between the two strings, incrementing through the candidate list and passing that into the value that's passed in, ultimately returning a true if I find a match, and if I don't, it's going to pass through the loop, returning a false. Finally, the last function of my smart contract, just returning the candidate list as a public function, returning an array of strings. That's it. That's all for my smart contract, and still pretty simplistic. However, we're building on what we know and slowly expanding our repertoire with Solidity. Let me move forward, and I'm going to put in my React.js application. So let's do that. So here I'm going to go to the source directory, back out of this, and go to source. And here I have the default app, and I could have done a npm start and test that, but I have pretty good confidence that's going to work appropriately. But in the case that you might want to step out and break down a problem that may be occurring with React, it's a good way to run that default program and test to make sure your installation worked appropriately. But I typically don't have problems with the install. Here, let me modify the DNS. I'm following through the similar process I did in the day 2 tutorial, but we're going to go back and break down the application line by line. First, let's get it up and running, and in order to do that, I need to update the DNS. Remember, if I'm going to be shutting down my node and bringing it back up, a new DNS is going to be applied. So I'm going to have to keep an eye on that in both the Hardhat config file as well as the app.js file. Finally, I have the deployment script. This is following a similar fashion to what we had with the earlier example, and it's not that much different here. So I'm going to load that in here, and we can take a deeper look at it later. Now, with the Hardhat initialization, we don't have a scripts directory, so I'm going to do a makedir scripts, cd to that, and create a deploy.js file. And I'm going to copy in my file, and I don't have to change anything here. Okay, it's going to perform the deployment. It's going to create two files, one with the contract ABI and one with the contract address. We'll be looking at greater detail as we run the application and look at the diagnostics from the developer console. Finally, I'm going to put in my assertion testing. So I'm going to go to my test directory, and here I have a test for the lock smart contract that I deleted. Okay, so I want to remove that. I'm going to put my test for the voting application, which we are going to be leveraging. I'm going to just copy that in. Let's run it first so we can break it down and see the details on how it happened. Well, first let's run it. I'm going to do that by going back to my main project directory, do npm, or npx rather, hardhat test. Got some warnings, okay? And we're going to keep eye on the warnings, but I'm not going to let it slow us down, okay? Because when you're working with all these libraries, and especially with React, you're going to have a lot of warnings. The most important thing is you have a successful completion. But again, we're going to keep an eye on it and document any of these issues, and I try to keep them along with the main directory of the GitHub and the bottom of the README install. Okay, so we can make sure that you have the highest likelihood of running these applications successfully. So I did a clean compile, and the deployment worked test. I did a variable test on the first string and the second string independently. We'll do a breakdown on that. Here I have a information and JSON based data on the deployer of the smart contract, as well as the individual address, which is obviously matching the address function here. So I could index in to this JSON based definition and take any of those individual values and check them out independently. Similar nature with the deployer, as you notice, the deployer and the first address of the owner is functionally the same thing, and we'll break it down and take a look at the assertion testing. Finally, the vote, we have a test that takes one of the candidates and performs a vote on that and manually increments it and compares it. Did my voting function actually increment it by 1? And it did, and it successfully passed. So let's take a look at that and see exactly the logic that was applied here to get this up and running. So I'm going to go into my testing script, and here I have a describe function. Again, I break down a little bit more detail on, I believe, the day 3 tutorial. We start getting into assertion testing. Here we're expanding on that. Here we're deployment in similar nature. I'm not going to spend a lot of time on this one. It's just a deploy contract, and simply make the test that I get a successful completion without any errors, which I did. Do another deploy. In this case, I check that candidate list, and I can directly reference it as a public variable. I do want to point out, though, between the JavaScript world and Solidity, here I use a curved parentheses, okay, as opposed to curved brackets, as opposed to square brackets, okay, which I use in Solidity. So that's kind of unique and perhaps not intuitive, because you might think that you would use the square brackets, but that doesn't apply when I'm performing an assertion test. You want to keep that in mind. Also, the fact that is indexed from zero index. And here I hard coded that directly to the incremental, the first value that's being passed in, the second, the candidate 0 and 1 being equal, and it passes appropriately. Here is where I check the address from the deployed contract, taking the contract address and the deployer. I'm also illustrating indirectly the relationship between what we identify as owners, of the first position of the owners and the deployer are known as one and the same. The square brackets around deployers essentially give me the functional equivalent of the first account. Now, when we start leveraging wallets, okay, we're going to be using any number of accounts, but in any case with the deployment, it's traditionally associated with that first account in the Hardhat environment, okay, being pulled out of get signers. Also want to point out through the deployer address, okay, that we have Hardhat voting. We're looking at the runner address. We're making a distinction here between the address of the smart contract and the address of the deployer of the smart contract. Two different addresses, so you don't want to confuse the two, and this is a good start. Writing them in the assertion testing. This is testing your knowledge, okay, so you can leverage this towards bulletproofing your smart contract and testing your knowledge of the smart contract. And you can even match this, and I'll put together perhaps some other examples where we do comparisons between this and some of the earlier examples I did with testing at the Hardhat console. Okay, it's very similar, and it's a very good bridge between the two and a reinforcement of your understanding. Finally, I do a deploy on the smart contract, and I pull the votes, the current votes for a given candidate, and then I increment it manually. I have to use big int. I can't increment it with, let's say, a plus plus. I have to add a big int converted 1, and then I call the vote for candidate and actually increment the vote through the smart contract and retrieve that, and I compare the two. Did it actually increment it as it should? And it did, and it gave me the appropriate response. So that sums it up for the testing of the smart contract. Now we can run the decentralized application, and again, we're going to do it in the same fashion that we did in the day 2 and beyond. And we do npx hardhat node hostname and bring up our personal blockchain with the Hardhat environment, right? Grab my DNS, go back, put that in here. We're going to get our 20 accounts, and everything is going to come up appropriately. Next, I'm going to do a deployment, and I can deploy it directly to the local host. It's going to know where to go in this case. But I have to go to my Hardhat project, right? I have to go to voting to be able to do that. So back to earlier points. So now it gave me a complaint with the deprecation of Pony code. Okay, we're going to keep an eye on that. But it did a successful deployment. We saw that in the back end here with our blockchain as well. Now I can do a start, and we can bring up our application, and let's bring it up, watch it run. As usual, I'm going to pull in my DNS, and I'm going to check for at port 3000, and here it started up fresh, and I'm going to bring on my developers console because I'm console logging a lot of information here. And again, this is a great means of doing additional testing, and as you note here, I have my accounts and a lot of other things that I've console logged along with my address and the AVI information. So I can press on the associated votes here. I pressed it 4 times, I had 4, and I can press this 5 times, and I can refresh it. It gives me a secure connection error when it's on HTTPS, and intermittently, if I go just to HTTP, and I've documented this, it works appropriately. Okay, so I think that's related to a security certificate. It may be browser related. In any case, if you have that error, just go back to HTTP, and I've documented it. It's in the GitHub with screenshots and everything. so you can effectively work through it. So there you go. I can do the votes. The votes are updated. Let's break down my React application at this point. And the deployment script is similar as before, so we don't have to spend a lot of time on it, at least at this point. We start expanding on it, and we'll be digging a little bit deeper into it. So let me go into source, app.js. I'm going to go down line by line. I bring in React and Web3. And again, I may have another variation working with ethers.js. Here, very comfortable with Web3 in the context of React.js. So it's still a relevant technology, so it's still not a bad way to go. Here I bring in the ABI and the address in similar fashion that I did with the day 2. With the component will mount. This runs in the background. This is going to load in my blockchain data in the very beginning, and when I did the refresh, that's exactly what happened here. Console log the address API, and I brought on my provider. Now, moving forward, I'm going to be presenting content of wallet integration. So the wallet integration is ultimately going to occur, and I have a variation of this, experimenting with other accounts, and the value of the accounts, which I'm not going to look in this video, but I can vary the accounts. That is going to eventually be pushed to the use of the wallet, but you can explore the dynamics programmatically and even get some insight as to, hey, how do I write my own wallet? Okay, that's a great exercise, and time permitting, I'll try to put content around that as well. I read in the ABI into contract, and that gives me a direct reference to my contract. I can do contract methods and reference all my public methods as I do here. I pull in that candidate list and I log it out. We saw that in the log. We can go back and take another look at that. Here I grab the total votes. Now, with the maintenance of state, I directly hash into state using set state. And I'm not doing an explicit declaration of a hash structure because the state values, as you see down here under this state, they function as key value relationships. So I can say, in this case, put a name and a parse int count, and that'll give me state that's referenced throughout the entire React.js file in this case. Okay, and I take the 2 votes from in the backend, and I can present it to the screen as you saw in the refresh here. The constructor has some basic values assigned, but again, everything could be hashed in directly. But if I can do it explicitly, in some cases, it's appropriate. Okay, now I have a function for voting. I'm going to bind it at this level. This is going to allow for access within the HTML that allows for the connection of the key button to the voting. Now, with voting, it's an asynchronous operation. That's important to note that, and I'm passing in a name. I'm not custom tailoring it to a given name, so that's important to note that. And it's also important to know how I stored that in state because it is somewhat unique. Not only how it's stored as a key value, but how I'd reference it. So I can actually hash in the state with a square bracket name, and it's going to give me the count as is associated by the parameter. So I have a lot of flexibility. This could be changed for voting for, let's say, among 20 issues, and I pass in the name of that issue, and I can vote on that and retrieve the votes appropriately. Now these two functions, I have the vote and I have the method that's going to grab the total votes. But I don't use this count, if you note here, and I'm going to print that out. We're going to take a look at that. I actually pull the count from my global state and increment it manually. Why did I do that? Okay, this is avoiding, and you can look at my earlier video and draw the means of comparison. And the dynamics may vary, okay, especially if you're using a wallet. But in this case, I have somewhat of a race condition, okay, where I have to actually refresh the entire application to get the actual vote from the blockchain. Okay, so I'm going to retrieve it from global memory, update it manually to be printed to the screen so it looks consistent, as well as write it to the blockchain. Now it may or may not work, but in this case I'm going to guarantee it to work, the interface, and most importantly make it consistent with what's expected to be updated to the blockchain. And that's accomplished by retrieving it from state square bracket name. And again, this is a little bit non-intuitive, okay, how it's being referenced, but this is very flexible. And increment it manually, and then I update it incrementally, and I write it back to the state. And that's it. Then I have the render here, and that's where I have the two buttons that were bound to this application, and I print it out appropriately, and we saw it work as intended. Last thing I want to do is restart it again, and I can restart it. I don't have to redeploy. I'm already deployed the smart contract. The values are stored, and we're going to prove that because we shut down React.js. We're going to bring it back up. Let's do that and watch it run and look at the count value as indicated here. So npm start, it should start back up, and I can go back and refresh my screen. I have Webpack compiled successfully. Hey, we're going to have warnings, okay, with Babel and these other things, but I'm not going to worry about it, okay, until they're showstopper. We're going to keep an eye on it. Here I'm going to refresh it, and it went back to 4.5. Let's do another increment here. I have count, and this is what the votes received gave me, if you recall, but I had to manually update it. Okay, when I refresh it, it's going to be reading it directly from the blockchain, which is going to give me the appropriate values. But I want to see it updated immediately to the screen, and that's why I did it that fashion. And again, with the wallet, may change the dynamics a little bit, but here I have, again, this is a factor of the asynchronous operations being performed, and that everything may not be updated immediately to the blockchain and read back out, and you might be able to affect the performance by putting in some type of sleep function, but again, that's not really clean in this case. And again, the integration of a wallet may change the dynamics with this application of wallet, but in either case, it helps us understand the dynamics of working with a backend network with an end-tier type application with our React.js. So that's it. Thanks for listening. Hope this helps. Everything's documented on the GitHub. I'll see you on the next video. Thanks. Take care.